Hello everyone, this is Guy and Helmers from Genome Studios here with another O3DE intensive. Now I have been gone for quite a while and have learned quite a lot more about the character controller that I've been building. And so I wanted to return to our physics character. Now, the very first video I ever made was learning events through physics character, but part of this lesson was, events and inputs and stuff like that. So this time I wanted to do an upgrade to the physics character, but gloss over some of those other things a little bit more quickly. So if you follow that video or other tutorials, you'll have basic input with a forward, back, left, right. In our case, I have keyboards inputs, WASD. And then for our case, we have an input move event that provides a move axis, which is a vector 2. And then for other tutorials, we have things like input jump and destination route, which is for pathfinding. But I wanted to kind of cover why we're reviewing this and updating this. And it comes when you have a gajillion assets on your game and your frame rate isn't unlimited at this point. So if I just click play here, you'll see that my FPS drops to about 60 from the editor's 170 or whatever it was. And if I hold left or hold right, you can kind of see it's very weighty and heavy. The character takes a bit to accelerate, takes a bit to decelerate. And well, then you can go, oh, I want my character to move faster, move slower, increase the speed and stuff like that. But if you then go and turn your camera to somewhere else or load a different level that's not so graphically intensive, and we get rid of all of our hermanubises. I'll get rid of that one too. And we have now 190 frames per second. If I click left, wowza, I go fast and far and quick and whoa, it's just pew, pew. It's like being on ice. It's just wowza. And well, this is caused by the fact that in our logic up to now, we have not been using frame rate independent logic. So when the frame rate is high, you get more updates than if you have a low frame rate. And this is not appropriate for movement. It's not appropriate for a lot of gameplay things. And this was caused by a handful of things, but I'll cover it more slowly. So as part of that last tutorial, we made a player controller and we made a separate player unit or just unit. And the reason for this is that you're decoupling the brain from the body. So in this case, the brain is the player and the body is our character that we want to move around. So in our player, we do what you're supposed to do for most controllers, which is register to listen to my forward, back, left, right input, and then we store it or process it however we want. And then what I was doing is that OnTick, I was sending input move to our unit. So the unit would receive that event and update its own understanding of what direction it's supposed to go. And then on its tick, which is relative to physics time, physics tick order, which you can see in our physics and tick bus video, we're updating. Oops. We're updating. Now, what most of you may understand is that when you're moving your character, there's a point where you take the direction you want to go and you multiply it by your speed. So that's the speed value I gave, and now I'm moving at that times or direction times speed. So on this little indicator here, it's 10 times the direction, whatever that means. But then we apply linear impulse, and this is where our frame rate dependent logic kicks in, is that if we're ticking physics 200 times frames per second versus 60, this apply linear impulse will get fired 3 times more. So that means our speed and our direction will get 3 times more involvement in forcing our character, which is what we saw with the many Anubis, whatever, we had a low frame rate, so we had low speed, and then without the units, the towers, the statues, we had fast movement. So the reason for this is because, as I was describing, the frame rates change, and the frame rate causes this to behave differently, and that's called frame rate dependence. What most games then do is once you have your final force that you want to do, you then go, how much force should I do this update, right in between these two? And that comes from, in this case, multiply by number for a vector 3, because we're playing with vector 3s right now. And this multiplier, we can go and derive it from our delta time. And this is how almost all games handle frame rate independence. So if, in this case, we're firing 3 times faster, well, that will make this delta time 3 times shorter. And so then if we're updating, 10 times slower because our frame rate is, 1 FPS or whatever, then this delta, from 1 frame per second, will say 1 entire second has passed since the last frame. So then this will go, hey, multiply by full force here and just go all, full force. So that's great. We'll do that, and that works wonderfully. And we've got frame rate independence. Or do we? Now, this is the second interesting little thing that I learned, and it's a lot less common in regular game engines or other game engines, is that I, through these events, which happen, whenever events are able to be happening for input, am storing this and then basically waiting, and this is the frame rate dependence now, waiting for the next tick of my controller, which just is the brain, so nothing's happening. And then at that tick, it's saying, okay, tell the unit that you have new movement inputs. So then instantly on that tick, the unit will get that change. But then on its own tick timing, whatever between this tick, then the event sending, then the file or the variable reference updating, and then this next tick that it's going to get the local variable, who knows how much time passed. It's completely untimed, unarranged. It's just they're happening when they happen. So this causes another frame rate dependence, which is the dependence of the frames between different ticks of different objects. So in order to fix this, we have to go to our brain. And instead of having our input move updates, what we want to do is rely on the event bus system of the game engine, which means let's make sure that every event that's going to happen happens, and then we handle things on the tick, which is our character moving. So receiving our inputs don't need to have timing involved. Updating our variable doesn't have to. Sending the signal can happen as instantaneously as the inputs come. And then processing the signal can happen as instantaneously as the signal comes in. And only then do we then start relating it to some sort of timing of last frame and this frame and that frame and next frame. So in order to fix that, all I do is we're setting only a part of the input on a vector 2 because we're using flat forward-back axis, so -1 to 1 for forward and back, and -1 to 1 with left and right. We're combining them onto the y-axis or the x-axis, and well, we have a constantly updating reference. So if we change y to 0 and nothing else happens, the last other movement inputs are still there, so that's good. You're preserving that input data that you have. But now we are instantly saying if at any moment our input changes, we're going to make sure that the unit is aware of this. So now, no matter what the event is, hold, released, left, right, or forward and back, when it's done doing whatever it's doing, it says, hey, unit, you've got new input. We don't need this tick at all. You may need it in the future for other things, but we can delete it for now. And now we're, as fast as we get input, we're passing it on. The unit is getting it as fast as it can and is now processing it when it comes. So now we have process it as whatever the variable is, all the way to by frame rate, by the frame rate, and let's give it to our physics character to now move. Last time I did this tutorial, I found out that I needed to boost my character's movement speed by quite a large factor. So I'm going to put it up to 500. And let's test. Now, when I move left and right, oh, my gas is not even high enough. The friction is just far too strong. Maybe 5,000? Okay, so see, now we have some of the movement based of kind of how we saw it before. You know, it's kind of slow to start. You let go, it kind of keeps going. Kind of slow to change, slow to all this stuff, right? But we're at 190 frames per second. Now, if I take my Hermanubis, this is kind of an annoying part of this. Duplicate, duplicate. Now we're going to take these two, duplicate these, duplicate them more. Now let's grab a bunch. We're going to duplicate them. Oops, wrong axis. Going to duplicate them. Duplicate them. Now we're going to grab more of them. I bet you can understand what I'm going to do. Duplicate them. Just so that we can get a nice high poly thing that's going to just absolutely tank our frame rate. Let's say that's going to be good. When I click play now, I'm at 70 frames per second. But when I move pretty well as fast. It's a little bit stuttery visually, but you know, I'm moving just as fast. I accelerate just as fast, decelerate just as fast. And I mean, you can't tell because you're not playing, but the game feel behind this feels about the same. And this is at half the frame rate, a little bit more than half the frame rate, meaning that this should have halved in speed of update. So now we see that we have frame rate independent movement on our character, still based on physics changes. And our little NPC here can't move because his movement force is tiny as well. So I'm going to delete these Hermanubises. Now that we know that we don't need them to prove what we're doing, I'm going to quickly look at my review here. Frame rate independent. Good. So we're at the end of this lesson, but I wanted to do one last addition, which is we have our move axis, which is our kind of intended direction. And this is, you know, from an x and y value, we're putting it here to basically say we're not going up or down, we're only going forward, back, left, and right. And that's just going straight into our stuff. But this actually gives us our like final intended direction. So what I actually want to do is go add another vector 3 and go desired direction. And I'm going to just plop it here. Oops. Clear connections, convert to reference, desired direction. You can take this, make it into a reference, and put desired direction here. Make this also into a reference, desired direction. Now this is because when we start rotating and moving and doing relative movements and stuff, we still need to know what direction we actually want our character to be going. And so in our next lesson, we're going to actually be using this desired direction to do things. So that primes us to get some character rotation and camera rotation and character to camera relative movement, which I'll cover in the next tutorial, in the next intensive. So stay tuned. I hope that your character is now nicely frame rate independent and that you understand why you want frame rate independence. I hope that you understand that utilizing the event system until you can't is a great first kind of rule of handling frame rate independence, and basically only use frame rate timing based things at the final presentation / processing of what you're doing. So if you can have something only be on one tick of one component, you're probably able to process that data as accurately as you can leading into that moment by moment tick. So thank you for watching, and get primed for some rotation. That has been a long time coming. Sorry that I haven't been able to get these intensives going out as much as I wanted to, but the dust has settled on some pretty intense work that I was doing in Genome Studios, so I managed to get some time here to get you guys up to speed here. So stay tuned. Next intensive will come pretty quick, because I really want to get you guys updated with movement and turning, because that's going to get you all set up real nice. Thanks for coming, and I hope that these intensives, help guide you to understanding this engine a lot more than when you started these guides. Whoops. Anyways, thanks for coming, everyone. See ya.